Hello everyone and welcome to the IFST Sensory Science Group webinar, Who Needs AI When We Have HI? My name is Stephanie Mitchell. I'm the chair of the IFST Sensory Science Special Interest Group. The group allows members interested in sensory science to engage and share knowledge with fellow professionals. We cover a wide range of topics relating to the sensory properties of food and drink, including sensory testing and analysis, consumer trends, neuroscience, the impact of social networking, and health and wellness. We are also involved in accreditation and examination of sensory training, and the review and promotion of ethical and professional standards. This webinar is the fifth in a series, replacing our planned June conference, which was cancelled due to the COVID-19 pandemic. Please keep an eye on the IFST's events page for more details of the next webinar. Feel free to make comments and ask questions throughout the webinar using the Q&A function, which should be at the bottom of your screen. There will be a Q&A session after the presentation where we will respond to as many of your questions as possible, and Carol Ryatha, a member of the Sensory Science Group Committee, will ask these questions. Our speaker today is Lauren Rogers. She's an active member of the IFST's Sensory Science Group and currently leads their accreditation and education working group, helping to coordinate their range of sensory science qualifications. Lauren is a freelance sensory scientist living in the beautiful Staffordshire Peak District in the United Kingdom. As well as working for several different clients on many different types of projects, Lauren also lectures on sensory science at the University of Nottingham and Le Cordon Bleu. She loves to run training courses in sensory science and related topics. Lauren is particularly interested in the sensory, consumer and emotional attributes of brands, sensory shelf life, panel performance and sensory claim substantiation. For more information on her biography, please have a look on the website. So without further ado, I will hand over to you, Lauren. Thank you.
Thank you for the introduction, Steph, and thank you to the SSG Events Group for inviting me to speak about such an interesting area. Who needs artificial intelligence when we've all got human intelligence? I'm planning to give an overview of artificial intelligence to begin with, and then share some applications of AI in sensory and consumer science. I've put several of the applications to use, and I'm hoping to use others in the future. However, I'm not an expert in the area of artificial intelligence. I'm just interested in how it can help sensory and consumer scientists. So if you spot an error, please write and correct me. We're then going to finish up the webinar with some questions from you, which Carol will be moderating. So let's start with what is artificial intelligence? Seems like a good place to start this presentation. Unfortunately though, there isn't one definition of AI, but many different definitions. There are disputes about the definition as well, and even about the words used. Some workers in the area wonder if the term intelligence is actually a misnomer. But the definitions here could be basically summed up as using machines to help humans solve problems, which sounds pretty good to me. You might be surprised to see the word sense in that last definition there from FutureLearn Artificial Intelligence online course. AI is actually becoming aware of the world around it. It can analyse images, sounds, speech and text, which I will cover in the presentation, but it's not yet able to taste, touch and smell. To make things more complex, there are also different types of AI, and this is probably where some of the disputes from around the definitions come from. To start off with, we have weak or narrow AI, which is where we see most of the current applications. This is where AI is designed for a specific task. Think about talking to your phone or talking to your computer and asking it a question. Sometimes the question comes back in text, sometimes the question comes back with their voice, the computer's voice. But perhaps this weak or narrow AI can't really be described as intelligent, particularly when you relate that to human intelligence. Then we can move on to strong AI. So this type of AI does have intelligence like a human brain, which is actually quite a big ask. And then we have super AI, which is also called conscious AI, And this would actually involve a machine being self-aware, which is very unlikely in the near future. But even with these definitions, we have disagreements. Some workers in the area don't include super AI, probably because we can't yet define human consciousness. So we're very unlikely to create a conscious AI in the future. Maybe we should think about what intelligence actually is. So have a think about that for a moment. Can you define intelligence, or your intelligence even? The dictionary definition says the ability to learn, understand, and make judgments or have opinions that are based on reason. So I think it's fairly reasonable to expect a computer to do that myself. The trouble is, though, is that we might all own a brain, although mine goes missing at times, but we have no idea how it actually works. Alan Turing, who was a brilliant British mathematician, laid the groundwork for modern computing. He published a paper in 1950 which discussed whether computer output could actually be compared to humans. He described a really neat experiment where there was a human reviewer and they would have a conversation with two people, just not voices but with text. One of the people was a human and the other was a computer. And then the reviewers had to decide which one was a human and which was a computer. So this kind of makes it seem a little like a duo-trio test, but maybe it should have been several humans and several computers, more like a difference from control. Maybe that would have made it a better experiment, I'm not sure. Anyway, if the human reviewer couldn't tell whether that it was a computer they were conversing with, Turing said that it would have passed his test. So you might have seen this in the film The Imitation Game, where Turing asks the question, can machines think? So it's quite an interesting thing to think that he did that all those years ago. So AI was actually formally defined in 1956, and that was when the world was still in black and white. So it's quite a long time ago, really. So AI has been around a long time, and over that period, there's been several surges forward, and other times that people refer to as AI winters, where not a lot happened. But recently there's been a lot of growth in the area, and there's been some articles in the news. You might have heard Elon Musk discussing artificial intelligence, and you may have been rather frightened by the whole idea, especially when he says, if AI has a goal and humanity just happens to be in the way, it will destroy humanity, and there he means it as AI, as a matter of course, without even thinking about it. It's just like if we're building a road and an anthill just happens to be in the way, we don't hate ants, but we're just building a road. So it does sound rather frightening. And what images come to mind when you think about AI? Perhaps a scary image on the right? Or maybe a collaborative robot or cobot on the left. Its name is Pepper and looks rather cute, doesn't it? But for sensory and consumer scientists at the moment, this might be a better representation of AI, which is probably a lot less scary, well, for most of us maybe. So let's look at some everyday examples of artificial intelligence that you might be very familiar with. This is an example of narrow AI. So I was looking for a photo to show someone, or sometimes I'm looking at my photos to find something to use in a presentation. In this example, I was looking for the word market, and it brought up some really nice pictures of some markets I've been to. But then I noticed this picture at the bottom, a picture of Hal McPhee at Pangbourne last year. And I thought, well, that's not a picture of a market stall, is it? Mixing up the picture of the stand there as a market. But then I looked a little closer and I could see the word market. The title of the paper that he's referring to is Use of Multi-Market Preference Mapping. So I thought, goodness, so the AI is actually looking at my text in my photos as well. So perhaps this type of search could be very helpful if you take photos at conferences or use the screenshot function to keep a track of publications that you've read. So maybe I'll keep that handy tip for myself. Every time you do an internet search, AI is powering the search. So your spam filter is even operated by AI. And if you've ever had a conversation with a customer service chatbot, Some of them are almost like chatting to a human. You can see here this chatbot that I was talking to, asking about the weather. It says, "Hey, I'm not a meteorologist, but I can say sometimes it shines and sometimes it rains," which does sound almost human, but perhaps it was programmed to say that. Here's another example of artificial intelligence that you might be very familiar with. So you might be talking to the Google Assistant or Siri or Cortana, Alexa or Watson. So in these two examples, I've asked Google about the weather, which it was wrong, but I guess it can't be blamed for that. And of course, if you have Google Home or Mini, she might answer you. I often ask, "Is it going to rain today?" And she will answer, "It's likely," and then will tell me when it's going to rain. And then I ask in the center there, the image is when I ask Cortana about the time in China. So other everyday uses of AI are traveling using directions from your phone, or those recommendations when you're online shopping or browsing. So perhaps AI isn't quite so scary because you probably use AI every day. Okay, so now you have a clear idea of what AI is. It's a set of technologies that allow machines, computers or robots to think and act like humans. And you've probably seen some of those examples that I gave earlier. You've seen them in action yourself. But what about things like automation, machine learning, robotics? Are they AI? Well, automation, like receiving that email reminder about the dentist, that's not really AI. Automation is just getting a machine to follow a set of rules in a specific order. The machine isn't looking for patterns, it's not learning from its experiences or finding the right decision. So automation systems might deal with data, but AI systems actually understand data. Looking at big data, certainly linked to AI, but AI is used to analyse big data. In fact, it's harder to analyse big data without AI. Data science, well, that encompasses lots of things, but it's often used to describe machine learning and deep learning. Just to confuse us, I think people like to bandy these definitions around and just make it more complicated than it needs to be. And of course, things like mathematics and coding, they're all the building blocks of AI, but they're not necessarily AI per se. The diagram on the left is surrounded by the technologies that do make up AI, so things like natural language processing, computer vision, neural networks, machine learning. But let's have a look at some of these in relation to sensory and consumer science. So the first application of AI in sensory and consumer science that I'd like to talk about is smart speaker technology. So let's imagine you were running a survey where the consumer was busy using the product. Basically, they're using their hands to assess the product. Maybe they're mopping a floor or washing their hair or using a shaving foam or eating a whole meal with a knife and fork where it's difficult to stop, and even stopping might change their view. So the questions would actually be asked aloud by the speaker device, and the consumer would answer verbally as well. So if you're interested in this, would like to see a great example, then do watch the recent Society of Sensory Professionals webinar, where General Mills and Igora worked on a project together to investigate the use of smart speakers for survey data collection. There might be some potential for better open ends from this type of survey, especially if you're going to develop a survey maybe that you want it to be more conversational rather than the standard surveys that we run at the moment. I'm hoping to use this technique in an upcoming temporal check all that apply, a TCATA experiment. So I'm quite excited about using this technology for something other than checking the weather. The next one I'd like to talk about is machine learning. So instead of following rules-based algorithms, machine learning builds models to sort, classify and predict from data, and it's generally large data sets. Let's say we want to use machine learning to predict how well a product will do in the market using previous data. We might have data such as liking scores, attribute liking scores, analytical sensory data, maybe even sales and instrumental data. And usually we use an algorithm. An algorithm is a set of steps to accomplish a task or some instructions to solve a problem. So think here like a computer program that you might have done at school. So we usually use an algorithm based on statistical analysis, for example, like preference mapping. In the example on the left-hand side, we take the data and the rules, and they're fed into the algorithm, and we get the results out. The algorithm that we create stays exactly the same. But if we adopt to use machine learning, we swap the rules and the results and use the results to help build the algorithm. So as you can see on the right hand side there, we take the data and the results to build the algorithm, and then the machine uses the algorithm, builds a model to create the rules, and it does this by learning, and that's where the term machine learning originates. So let's look at an example of that so that it can try and bring it to life for you. Here's an example from a consumer study that I ran in 2018. It was a bit more complicated than I've shown here, as I've removed several of the attributes from the trained panel, so it's just leaving us with a handful. But let's just look and see how it appears on this screen. So consumers were asked overall liking using the 9-point hedonic scale. That goes from 1 dislike extremely to 9 like extremely, and that's shown on this tree map here with the letters OL. The consumers were also asked a final question: would you buy this product if it was available at a reasonable price, etc. And there they could answer yes or no. So if we start at OL, overall liking, at the top, the model quite clearly shows us that if overall liking is more than 4, and then more than 5, right over on the far right hand side, consumers would generally answer yes. So we've got 1,249 consumers answering yes. However, you've got 12 consumers there who answered no, despite scoring more than 5 on that 9-point hedonic scale. So consumers who gave a score greater than 4 but less than 5, as shown by the orange highlighting, appear to be affected by the scores for attribute 3. So that's a trained panel result. So if you can see the trained panel result was more than 26 for attribute 3, then consumers would generally say yes, but no if the result was less than 26. Then once you've got this kind of information, humans can actually go and look at that data to understand more about these results and think, well, why are there 36 people saying yes that were wrong, and 36 people saying no in that situation? So the AI is actually helping humans by pointing out where to investigate further. So it's given us help to understand our data. So let's look at one of the rejection stems on the left-hand side. It seems that when consumers score less than 4 on the overall liking scale, and the trained panel result for attribute 1 is more than 49, consumers would generally say no. You can see there it's 595 of them. That's shown by the green highlighting. And then you can follow the tree down the slide, and you can really understand more about the consumer's decisions. Now, to create this tree map, I used open source software called Weka. Weka is not only open source, but all the learning articles, courses and books are all open source too. If you've not heard the term open source before, it means free, which is often a very good price. You can also do machine learning in R, which is another open source free software package. You can also do machine learning in ExcelStat, and there's many other packages as well. The ExcelStat courses are all on their website or YouTube, and they have some really useful articles comparing different machine learning approaches and algorithms, so I can recommend that you go and read those if you're interested. And there are also a lot of courses out there for all the different software applications, and many of these courses are free, so you can learn quite easily online. Another interesting AI application is speech-to-text video transcription. In fact, you can use any audio to be transcribed. It's not perfect, particularly at the start, but once you've got the product trained up to recognise all your words, it can be very, very helpful. So for example, you might have some qualitative recordings from a focus group or interviews that you've done, and you would like to transcribe and use that transcription for your analysis. So for example, maybe we'd like to record all our QDA discussions that we're doing online at the moment. So in this example, you can see a descriptive analysis discussion on the left-hand side. So this is actually what was said in that discussion. and then you can see the AI transcribed output from otter.ai on the right. And it took it about 6 seconds to do this after it had listened to the recording. So this type of approach might not be as accurate as we might hope, but it's a great start. And with humans and AI working together on it, it can be much quicker than doing transcription from scratch. There are several online AI transcription services such as HappyScribe, Scribey, and Otter AI, which I used here. And most offer a free trial or even a free service, so give it a go. Some of the wrongly transcribed words are guaranteed to make you chuckle, so if you want to be lightened up, then try something like that. It's bound to make you laugh. As we saw earlier in the search for photos that are taken of market stalls, AI can also be used to assess and analyse photographs and images. It looks for patterns in the data that humans might not necessarily be able to see. Sensory Dimensions ran a great webinar earlier this year with folk from the London College of Fashion, looking at how AI can be used to examine changes in hair after treatment with a shampoo or conditioner. And in this study, they had 120 fine hair tresses, and they were treated, and they took images before and after the treatment. You can get more information about this because it's all been published on the link there, which I'll put on my website along with all the courses and other links. The analysis of text is something that sensory and consumer scientists tend to do a lot of. It might be your qualitative transcription that we've just used Otter AI to transcribe, or it might be survey data, open ends, and AI can be a huge help here. There's lots of different types of text analytics. You might like to write a report based on summarizing several reports or publications. Well, AI can actually do that summarizing for you. You might want to identify different categories mentioned in some open ends. AI can do that for you. You might want to look and count all the mentions of brands from open ends. Again, AI can do that. You might want to remove people's names from text for GDPR compliance. AI can do that. Or you might be looking for groups of related words from a bulletin board, for example. AI can help you there as well. So in this example, I've got 120 consumers with their overall liking score, as well as a column on open ends for liking and open ends for disliking. So for example, here the liking, you could say, what did you like about this product? And the person's put nothing. And they've obviously given an overall liking score of 2, so it shows you that they really didn't like this product. So in this example with these different biscuits, 5% sugar reduction, own label biscuit, a standard biscuit and a 10% sugar reduction biscuit, I'm going to use software called Caplina to demonstrate text analytics. But obviously other software is available. What I like about Caplina is that the human works with the AI to do the coding. The AI doesn't do the coding for you as such. So what happens is you've got all your data, and the AI shows you some examples of the categories that it's going to create. So it starts by making all those suggestions. So it gathers together all the mentions of crunchy, all the mentions of oat, and all the mentions of sweet. And then the human can check through and make sure that the codes are named how you would like them to be. Or you can create new codes. So for example, there for salty, you've got sweet taste, sweet, oaty sweet, and sweet salty. You might actually want to create a new code for salty, or maybe that was the only mention of salty that was made, and so maybe that code is not needed. Then using Caplina, you can download your results for further analysis or create data visualizations within the software. In this example, I've actually downloaded the data and created a graph. So you can see that the own label biscuit or cookie was described as pale in colour at the base of the slide there, while the 10% reduced sugar product had a bitter aftertaste and was often described as soft. So this whole analysis took me about 15 minutes from receiving the spreadsheet to getting to this plot. So as you can see, AI can really help us speedily analyse data. And while we're on the topic of text analytics, one of the analysis methods I didn't mention earlier is sentiment analysis. This is a really interesting area and an incredibly helpful technique. So I hope you can see from the definition and the diagram that text is fed into the computer and a value representing the sentiment is churned out. So the text examples here are from the liking and disliking open ends from that biscuit study. So for example, one of the consumers wrote, "Taste of absolutely nothing, too hard, too thick, and so bland." So you can hear the sentiment there yourself, and the computer has correctly generated a score of minus 0.9 for this. Now, the sentiment scale goes from -1 to +1, so it's nice and simple. In the centre here, you've got someone just saying it is a bit crunchy, which is kind of a nothing statement really. So that's been given a score of 0. Whereas nice, large, visible oats, nice and crunchy, just about the right sweetness. This is my favourite biscuit so far, has got the score of 0.9. So it's a really good way of categorising and distilling opinions in a piece of text. So let's say we wanted to run some sentiment analysis on some other open ends. Let's say we wanted to look at some data. We can quickly then create the sentiment analysis, paste it into the spreadsheet, and then sort the rows to look at the main problems. Very useful if you need a quick idea of the worst sample in a consumer study, for example, or you've got to look for the best or worst feedback in some reviews. In this example, I used a Twitter application programming interface, an API, to look and see how Coke and Pepsi were doing in terms of taste comments. When I did this, I ended up with hundreds of thousands of comments to wade through. But by conducting the sentiment analysis, which only takes a few minutes to assign sentiment to those thousands of comments, you can quickly sort by sentiment and then home in on the issues. So again, we've got the machine and the human working together to solve a problem. You could take averages, monitor comments over time. You can also do sentiment analysis on the other comments that came along with these tweets, or maybe you could do sentiment analysis on customer complaints. So lots of options for text analytics in sensory and consumer science. Another application of AI in sensory and consumer science is graph databases. Well, this is a computational method of organising and querying historical data, and it's made up of nodes, relationships, which are often a verb, labels, and properties. So in this example here, we've got the score at the centre, but we could change this to be the sample, or could be the panellist if you're making queries about samples or panel performance. It's very flexible, you decide. The nodes are a bit like the column headings in your spreadsheet that you've got of your data. And the relationships are things like the panellist assessed sample 7, so it's often the verb, as I said. For the score description, you'd feed in the question that was asked or the scale that was used for the assessment, so you can really understand everything about your data. And using the graph database, you can then find out information about a panellist, a sample, a recipe, and follow the data through looking for patterns. And obviously it's not limited to sensory data. You could link up to the recipe, instrumental data, packaging information, shelf life, anything that you would like to look at in the future and keep together and sort. So talking about graph databases and looking for these insights in historical data, let's look at AI-based market insights platforms. Market insight platforms are often custom built for companies, and they allow you to connect all your data and tools in one personalised kind of dashboard. Imagine if you didn't have to search endlessly for that file that had that result about that product, but you just can't remember the project name. And if you could find it, where's the questionnaire that tells you what questions were asked? And if you could find that, where's the consumer screener data to tell you who all the consumers are? So in this way, these market insight platforms actually look after the Word documents, the PowerPoint documents, the Excel files, and any other analysis file that you had in a folder. But that folder has a software package and makes everything easy for you to look at. One example is Market Logic, who kindly shared some slides with me for this talk. So thanks, Elizabeth, for your help. On the right-hand side, the AI and machine learning connect via a knowledge graph to build the insight engine. And then in the center, we've got the digital insights workspace, and that helps users find and research insights. And then the business assistant on the left-hand side gives answers based on intelligence, knowledge, and reports. And there are AI and human curators for this information. So again, we've got humans and AI working together to get the best results. One of the things that struck me when I saw this application in use is that all the historical data is tidied and connected and fed into the system. And this enables the researcher to quickly query past results, look at past reports, look at data sets and insights in just a few clicks. So the market logic system works by linking artificial and human intelligence together to kind of look after all the information sources within your business. On this side, you can see all the other packages that are available, such as Digimind and Sharper and Crayon and Northern Light. As you can see from the Forrester Research Market and Competitive Intelligence study, Market Logic was ahead in this area, mainly for user experience, the vision that it had within the product, the market approach. And one of the quotes there, everybody now knows where to start to do their own research, I think is a very good summary of these market insight platforms where they draw all the information together. It's very useful. So I imagine you'd quite like to see how this looked on a laptop screen. So this is the output. You can see it's personalised. It says there, "Good morning, Ernest." I know your name's not Ernest, but if it was, I'm sure you're feeling like it's very personalised now. The search is powered by AI at the top there, marked by the number 1, and it's personalised for Ernest, all based on his previous searches and interests, things that he's looking at the moment. The centre is curated by the Human Insights team. So again, humans and AI working together. And on the left-hand side, you've got the AI recommendations based on previous searches. I don't know if you've noticed there on the right-hand side, that's all the links to the tools that you might have within your business. So everything is all on one dashboard. So these market insight platforms are a very good use of AI technology. There are many more applications of AI in sensory and consumer science I haven't had time to cover, I'm afraid, such as assessing and judging emotions, linking sensory and instrumental data, the analysis of ethnography videos, the use of AI to predict aroma profiles. That sounds cool, doesn't it? Looking at IBM's Watson, using neural networks, robotics, using AI for translations, deep learning and chatbots, and I'm sure there'll be many, many more in the future. I hope you've been inspired to find out more about AI and can see the benefits that it could bring to your work, because AI works best when it works alongside humans. If you have been inspired, there are a lot of courses out there to help you learn more, as well as blogs and podcasts and tutorials. Agora might be a good place to start. As you can see from their tagline, they help sensory and consumer science teams prepare for artificial intelligence. There are various courses available from FutureLearn and Coursera and IBM, and a lot of these are actually free, and they really do start at the beginning, explaining clearly what AI is and how it can benefit you in the workplace. The Market Research Society also offer courses on AI. One of them, which is Applying Machine Learning to Your Data, is an excellent course which I can recommend. So in conclusion, to answer the question, who needs artificial intelligence when we all have human intelligence? I hope you will join me in agreeing that we all do. Thank you very much for listening. I'll now hand you back to Carol, and she's going to guide us through all the Q&A. Thanks very much, Carol.
Well, thank you, Lauren. That was an amazing presentation, and really brought up a lot of really interesting points that I'm sure everyone will find extremely useful. So as you said, we're now going to move on to today's Q&A session. Let's move on to the first question. Will AI change the way sensory and consumer scientists work?
Yes, I think so, probably. I was discussing this with a client last week, and we were thinking about a particular type of study. So say you were doing a study on floor cleaners, for example. If you were actually doing that, you might be conducting the study at home. It might be a consumer study, for example. You might be looking at liking of the product, maybe, or you might be doing a trained panel study, maybe measuring aroma intensity over time, or shininess over time, or something along those lines. So you might be thinking, oh, it would be good to do something like a check all that apply study. But the trouble is, while the person's washing the floor, they've got the mop in their hand, they can't see the screen, they can't get to the kata list to answer the questions. And it'd be really difficult if they had to stop and walk over to the screen to answer the question, then maybe they're going to walk on the floor and change the impact of the cleaner. So I was thinking, if you could use a smart speaker instead of doing that, you could have maybe something like a Q&A session with the smart speaker to gather that information. You could even do the check all that apply with the smart speaker. But how about if you did something like something more like free choice profiling, but with the smart speaker? You can invent a complete new method, something like free choice profiling with smart speakers. That's a bit too long, isn't it, really? But that would be amazing, wouldn't it? A whole new method just based on understanding consumers' perceptions or gathering trained panel output. And if you took that a step further, imagine if you were eating a meal and you wanted to understand what people were doing with the meal. Maybe you make something like a gravy and you don't want to assess it on its own, you want to assess it within the context of a meal. You could set up a smart speaker to actually record during a session where people were eating. They don't even have to put down their knife and fork to answer the questions. So I think that would be a really good way of understanding consumers' perceptions in the future. And I think there's so many people, innovative people out there, they can invent a brand new sensory method to cope with all of that and work with the smart speakers to do that.
Here's a question that's come through from a participant that might expand on something you mentioned during the presentation.
Mm-hmm.
And they say, is there any application of time response methods inside of AI? So I guess, can you use AI to help with time-based methods?
Yeah, definitely. If you were doing any type of time intensity profile or discrete time intensity profile, then I'm sure AI would be very big help. If you imagine AI working with the software that we use at the moment to collect our data, in the future, I'm sure that would be an amazing addition to understand that, because that time intensity data is so complicated, isn't it? You get so many data points and there's so many different profiles from different people. I'm sure AI would be a very good use of that, understanding that output.
Okay. There is one quite general question, but it's interesting, I think.
Mm-hmm.
How widely do you think AI is at the moment in the industry, say for its sensory consumer data analysis interpretation?
I don't know that, because I don't know what everyone else does, but I don't think it's very widely used at the moment. But I see clients starting to use it now, so I think it will just grow and grow.
And a few questions about, I know you did mention that at the very end, facial recognition technology.
Yeah.
And the use of AI in that. Are there any specific, I know that you're not an expert, so don't worry if you don't know the answer, but are there any specific applications you could think that might work well with facial recognition and AI?
Yes, because there's a company, Noldus, that are doing lots of work on this, looking at emotions and facial recognition, and then using that for sensory science. Unfortunately, I didn't have a chance to include that in the presentation, but if you go on their website and have a look, they've got lots of information, including setting up their own kind of learning about people's emotions lab. So there's actually a white paper that you can download to look at that. and understand more about how you would set that up yourself.
Okay. It's a very specific question.
Mm-hmm.
If you've measured this liking of a group of samples on traditional scales, how would you go about, or would it be useful to use AI to look for the best sample? What would it help, or would you get any extra info? Yeah.
I think so. If you think about the tree diagram, I noticed someone had asked what method I'd use for that. It was using the Wecker
Okay.
tree diagram, the J48, and that's based on the C4.5 algorithm. If she's interested, that was invented by Ross Quinlan. So I think to answer the question that you asked, yes, because you can understand and link in that tree diagram, I described sensory attributes. But imagine if you had the sensory attributes, your instrumental attributes, maybe sales data as well, or any other data that you had, you could really understand consumers' liking based on all different types of aspects. So not just the consumers' comments, but from the trained panel point of view. It's a different way of looking at the data, I think, because you're going into
Broader.
depth. Yeah, you're going into depth in each of those sensory attributes. And instead of just saying, well, you think bitterness is a key driver, and maybe doing some predictions with preference mapping, you're actually understanding what the cutoff point is. So above 45 or below 45, people would say yes or no to buying the product. Or maybe you could link it, instead of doing the yes and no, you can look at the actual liking score. There's lots of different ways of running that type of study.
Yeah. Okay. I have this is my question. Do you think, because so for all the different applications of AI that you talked about, and there's so many interesting ones, there's like different platforms or different software to use. Do you see in the future that sensory software will include some of these applications in a way that kind of comes as a package? Is that something that you think is likely to happen?
I think it's already happened, because if you look at the packages available in R and in ExcelStat for machine learning, a lot of those examples are already based on sensory and consumer data.
Mm-hmm.
So that's already there at our fingertips to use.
Okay.
And R particularly being open source, lots of different machine learning packages within R that you can use. What's interesting about R is that it has so many sensory and consumer packages, which makes it so special, I think, compared to Python or something like that. So yes, so they're already available.
Okay. There's a few questions about the image analysis.
Mm-hmm.
And you did speak about the example of the hair image analysis. Do you have anything else to say about that, about how it might be used in sensory studies, or any further thoughts?
It has a huge potential, doesn't it? If you think about taking photos of meals, even taking the photos, it sounds a bit gross, but maybe taking the photos of meals when they're finished, see what was left.
Yeah.
Some very good applications if you think about the restaurant industry, thinking about how things are plated. Lots of good research there from Oxford University on plating. If you incorporated the AI representation and analysis of all those images, as well as just their judgments, the consumer's judgments, lots of potential there for image analysis. And of course, in home and personal care products as well.
Yeah, that sounds really like a great way of using it. Okay, this is a specific question, but I think it's really a good question. Interesting. So with your example of floor cleaners and the smart speakers, do you think we'll ever get to the point that AI can make the questionnaire dynamic? So more like a conversation?
Yes.
Yeah.
That's a nice short answer. Definitely yes.
Yeah.
At the moment, it's all a bit kind of artificial sounding. But I'm sure
Right.
as computers learn to speak more like computers. I mean, if you think about how Google sounded a few years ago and how she sounds now,
Mm-hmm.
it's quite different, isn't it? There's a lot more, the intonation and the tone is a lot better. It's a lot more improved than it was in the old days. So I think yes. And I think that conversational element will be just amazing for consumer and sensory scientists, particularly in in the assessment of meals or any study done in context.
Okay. And it's not just about the actual tone of voice and things, but it's also about the whole way the questions are asked in terms of.
Yeah, if you think about how we do piping at the moment in terms of questions, you know, if the consumer answers this way, then go and ask this question. Well, with the AI, you've got so much more power because she can actually, I always say she, I don't know why, but she can actually understand using understanding of the text. If you think about the way that text analytics works, the computer is actually understanding what is said. It's not just following a rule, which when the consumer says yes or no to an answer, go and ask them this question. It's not that simple. They're actually listening to what you're saying, and there might be 30 questions that they've got lined up ready for the next question to ask. So
Yeah, amazing. Yeah. Which app of the AI applications, or which AI applications that you mentioned, do you think might have the biggest impact on how sensory and consumer scientists work?
they've all got so much potential, haven't they? I think in the current situation where it's more difficult to collect data at the moment, I think that the market insights programs like the market logic program that I showed, I think that's got the most impact really of all of the applications. Because if you think about all those data sets that we've got on our computers, all those agency reports, and they're all kind of gathering e-dust, aren't they? We're just not looking at them. We're not seeing all those insights in there. And I would love to have a platform like that on my computer to look after all my clients' data. And if you can imagine in the future, but then when you collect more data, it's all being stored in that package then, isn't it?
Mm-hmm.
And all those reports are actually being linked together.
Yeah.
So I think in the current situation, because we can't so easily collect data, looking at our old data and really, if you think about all those data sets that you haven't really looked at, you've done the main analysis, but you haven't really looked at all the open ends, for example. You haven't really looked at the different clusters, and do the different clusters have different open-ended answers? You know, that type of thing that really gets left at the end and maybe you don't have the chance. If you had
Yes.
some way of collecting all that information together, it would be brilliant. So I'd have to vote for one of those packages, I think.
Yeah, and just thinking from your presentation, it makes me see how much more sensory and consumer data could be used strategically,
Mm-hmm.
because it will be there as with all the other data that the company is collecting.
Yeah,
Yeah.
definitely.
This is also a really good question. Well, they're all good, but there's so many. I'm sorry for people I'm not getting your question answered. I just can't get them all. There's a lot of software to look at social media product review data, and you mentioned the Twitter APIs.
Mm-hmm.
How do you choose which one to use?
I would try several and decide which is the best, because there's lots of different natural learning out there that is a bit difficult to choose. For example, when I was doing some analysis, I find that if there's a lot of emojis and pictures and things like that used in the answers or used in the tweets, then instead of using the English NLP package, then I would use something called Vader, which deals better with slang and emojis and things like that. So I would say try the different types on your data and check it. If you think about when this talk was originally planned, we were going to run a workshop, weren't we? And look at sentiment analysis and then just look at all the different comments and what the sentiment was, and just kind of make a judgment for ourselves which would be the better options. So that would be quite a good thing to do. Run it through all the different types of packages. Lots of them are free online or allow you to do a free trial, and then decide which one works best for your types of comments, because everyone has different types.
Okay, I have another question, which, sorry, I'm hogging, but it's kind of my question again. If you kind of could go into the future and see like the sensory consumer department of the future, do you think sensory consumer scientists will be mastering these techniques, or will there be data scientists as another role and they liaise? How do you see that? Do you have any thoughts?
I think there will be data scientists and sensory and consumer scientists working together, because a lot of the sensory and consumer scientists I speak to are learning to program themselves, learning to do code. If they're not learning to do code, maybe they're not looking at the R packages and things like that, they're just actually using those R packages, because in some ways you don't really need to learn how to code. If you can see evidence of that package being used before in sensory and consumer science, then you can use that package. It's better to have an understanding of coding, but there are a lot of books out there that teach you the basics, and a lot of the sensory and consumer scientists that I work with are learning that to start off with. We have an R study group, which are called Struggle R's, which is a good term, I think, for us trying to learn how to code.
And is R being taught more in university? Is that?
Probably. I don't actually know that for a fact, but I imagine so, because of the fact that it's open source.
Yeah. Okay. That's great. Can you, I think this might be just about the last question.
Mm-hmm.
Could you explain how text analytics works in a bit more detail?
I could, but it might take a while. It's all to do with looking at the words, splitting up the words, learning about the grammar and which prefixes and suffixes go together, how humans construct sentences. But for the person who asked that question, there's a webinar coming up on that topic, all on text analytics. I think, is it on the 29th of October?
I think so, yeah.
Yeah, that's my daughter's birthday, so I thought I'd remembered that right. Yeah, that would be a good one to attend, find out more, because in that half an hour you'll get a lot more information.
Yeah, okay, that's great. I think we're coming up then to the end of the webinar. So I just wanted to say, first of all, thank you so much, Lauren. It's been a really amazing session. And I also want to thank everyone else from around the globe. I saw in the participants, it looks like we have people from all over. And as I said, we had a lot of questions. So if we didn't manage to answer your questions, you can contact Lauren directly, and her details are on the screen right now. And finally, we'd also like to remind you, those of you who are not familiar with the IFST, that you can find some useful information on the website, such as the COVID-19 Knowledge Hub, the Food Science and Technology magazine, and you can find out more about membership benefits there and how you might join the IFST. And new members are always welcome, so that would be great. You can check out those membership benefits. So finally, I'd like to say thank you so much again, Lauren. It's been a great hour, and everyone attending today. And also I wanted to thank Robin from the IFST for all the technical support in the background, and he's been great.
Thanks, Robin, yes.
So thank you, and goodbye, everyone.